Hi everyone. I hope you're doing well. Today, we'll be exploring how to implement a directional evade or dodge system in Unreal Engine using C++, similar to those found in AAA games like God of War. We'll be utilizing root motion and animation montages to play the correct animation. This system will be created as a separate component, making it easy to incorporate into any of your projects. Although I'll be demonstrating it with an advanced third-person controller, feel free to check out my advanced locomotion series, linked in the description. You can still use Unreal's default third-person template. Since the evade system is built as an actor component, the code will remain relatively independent. Welcome again. Let me start by quickly showing you the third-person controller I'll be using for this tutorial. It's the same one we created in the advanced locomotion series, but you don't need to use it. You can absolutely stick with the default third-person template if you prefer. To implement a directional evade system, we'll need at least 4 different animations. While I couldn't find the perfect dodge or evade animations on Mixamo, I did come across some that will work for our purposes. Of course, if you want to purchase animations from the marketplace, there are plenty of great options. For now, though, we'll focus on building this system, and you can swap out the animations later to suit your needs. I've downloaded 4 directional dodge animations and 4 directional roll animations, though the roll left and right animations aren't functioning quite as expected. For now, we'll start by using the dodge animations since they're symmetrical and work perfectly after being retarget. Because I'm using a character from the Paragon asset pack, I've also retargeted the animations to fit the Wraith character I'm using. I'll include these animations in the description for anyone who wants to use the same ones. If you're unsure how to retarget Mixamo animations to Unreal Skeleton characters, there's an excellent tool available that simplifies the process. I'll make sure to provide a download link for it. This application helps convert Mixamo characters and animations to match Unreal's skeleton hierarchy. In earlier versions, retargeting animations was quite tedious, but with Unreal Engine 5.4, it's much easier. After importing the Mixamo animations into your project, just right-click on any animation clip, choose Retarget Animations, select your target asset, choose All Animations, and hit Export. Now the question is, how do we manage these animations and decide which one to play based on direction? We have 4 distinct animations for forward, backward, right, and left movement. One approach could be using a blend space and driving it with values we calculate, which is a good option but adds complexity, especially since we don't have diagonal movement animations. A simpler solution is to group all the animations into a single animation montage, starting with forward and ending with backward. We can assign each animation a unique section name, then from C++, we'll fetch and play the appropriate one. Alright, let's get back to the engine and create the animation montage asset. Right-click to create a new animation montage. I've already done this and added the 4 dodge animations, creating a montage section for each one. You can create a new montage section by right-clicking and selecting New Montage Section, then renaming it appropriately. We want each animation clip to play individually when selected from the C++ side. If you just created the montage asset, you'll notice that playing the first animation will automatically play all the animations in sequence. We don't want this. To fix it, open the montage window on the right and click Clear to ensure the animations don't play sequentially. To play animations from code using animation montages, we need to add a slot node before the output pose in the animation blueprint. In the anim graph, right-click and add the default slot node. Newly created slot nodes will use the default slot by default, which is fine and can be left as is. As mentioned earlier, we'll be building the evade or dodge system as a separate component. This approach gives you much more flexibility, allowing you to easily add this component to any project you're working on. To get started, let's create a new C++ class and select Actor Component. An actor component is reusable and can be added to any actor. In our case, we'll add it to the character. Name it something like Evade or Dodge Component and hit Create Class. I've already created one, and we'll take a closer look at it shortly. Before diving into the code, we also need to set up a new input for the evade action. For the player to evade or dodge, he or she needs to press a movement input corresponding to a direction, combined with another key, like the left control. This type of behavior is known as coordinate actions, which I've covered in my advanced locomotion series. However, in this tutorial, we'll only create the evade button, such as the left control key, and in the code, we'll implement similar behavior. This approach helps avoid sending data from multiple classes. First, open your character class. In the header file, we'll need to declare a few variables and functions. Since we're using the enhanced input system, we'll create a reference to the evade input action and mark it as Edit Anywhere so that we can easily set it in the editor. Additionally, we'll add a flag to track whether the evade button is pressed or not. We also need a reference to the evade component, which we'll be coding shortly. There are two options here. We could either add the component directly in the character blueprint and then cache a reference to it, or, since we're writing the evade functionality in C++, it's better to add the component to the character in the constructor. Finally, we'll create an evade function to bind the evade input. In the constructor, create the evade component and make sure to include the evade component header to prevent any errors. Then, navigate to the setup player input component and bind the evade action to the evade button for both the started and completed triggers. We will handle the evade state using the flag we created earlier. Inside the evade function, we begin by retrieving the value of the evade button input from the value parameter and store it in the evade button pressed boolean variable so that we can check if the evade button has been pressed. Next, we immediately check if the evade component exists. If the evade component is missing, the function should return early to prevent any further actions. If the evade component is present and the character is not currently engaged in an evade action, this check is crucial, and I will explain why shortly when we review the evade component code. And the player presses the evade button, we then call the evade function in the evade component, which we will create soon, to initiate the evade action. In summary, this function monitors the input from the evade button and checks whether the character is actively evading. If the button is pressed and the character is not already in an evade state, it activates the evade action through the evade component. There are two additional tasks we need to address in the character class. First, keep in mind that evading requires two inputs, the evade button and the movement direction. This is handled within the move function of the character class, so we must pass this information to the evade component. The sendMovementVector function, which we will review shortly in the evade component class, receives the movement direction each time the player moves. We cannot optimize this process since we need this information before the player presses the evade button. Lastly, when the player is in the evade state, we want to prevent them from performing any other actions until the evade is completed. Therefore, if the player is evading, we should restrict their ability to move around, look around, or perform jumps. Now open your evade component header file, and we'll begin by declaring a few variables and functions we'll need. First, to determine the direction the player can dodge, we'll create an enum to represent the dodge direction. This will also help us trigger the appropriate animation clip, which we will see shortly. Each direction corresponds to a specific dodge action. These directions represent the possible dodge movements. When we review the source file, you'll understand why the none value has been included in the enum. We'll need a Boolean variable to track whether the character is currently in the process of evading. Additionally, we'll create a variable to store the direction in which the character will dodge. We also need a reference to the animation montage that contains the evade animations. Another variable, the evade section name, will hold the section name of the animation montage that corresponds to the specific dodge direction. Next, we have variables to control the visibility and materials of the weapon during the evade action. This is specific to my character because my character holds a weapon. If your character doesn't have a weapon by default, you won't need these. However, it's important to understand how to set up these materials in different states using delegates, which we'll discuss shortly. I also found a sound effect that we can play during the evade action. Additionally, we have delegates that are triggered when the evade animation starts blending out or finishes blending in. We'll go over how to bind these delegates to perform various tasks at the start of the animation or when it begins blending out. We also use timers to reset the evade direction. This function sends the current movement vector from the player to the evade component, allowing it to determine the correct dodge direction. The evade function kicks off the evasion process by calling the necessary animations and mechanics for the dodge action. It requires a reference to the character class as a parameter, which allows us to access the animator instance and play the correct animation clip. Lastly, the getIsEvading function is a helper method that returns the current state of the isEvading flag. This is useful when we need to check the evade status from outside this class, as we previously did in the character class. Now let's dive into the source file and go over the implementation and logic behind the evade component. I'll walk you through each part so you can understand the purpose of each variable we declared earlier. First, in the constructor, I initialize default values for several properties defined in the header file. Evade section name is set to an empty string. This is crucial because if the player presses the evade button by default, nothing should happen unless a valid evade section name is set. The isEvading flag is initialized to false, indicating that the character is not in an evade state by default. Evade direction is set to none, meaning the character isn't moving in any particular direction at the start. The reset evade direction time rate is set to 0.1. which ensures that the evade direction will reset 0.1 seconds after input is received. Don't worry, I'll explain the purpose of using timers and why it's necessary to reset the evade direction after a short period of time later in this video. The sendMovementVector function is triggered whenever the player provides movement input, and it's already linked to the move function in the character class. This function passes the movement vector to the setEvadeDirection function, which is responsible for determining the direction in which the character will evade. Let's take a look at the setEvadeDirection function. It's a straightforward process. The function checks the player's input, provided by the movement vector, to figure out the dodge direction. For instance, if the player is moving forward, where the y component of the movement vector is greater than 0, the evade direction is set to evade forward, signaling that the player intends to dodge forward. Similarly, if the player moves backward, it's set to evade backward, and for left or right movement, the x component is used to set the corresponding directions. If no movement input is detected, the evade direction is set to none. In summary, after calling this function, which is invoked every time the player moves, we already know the direction the player intends to dodge. You could further optimize this by ensuring the function isn't called if the input hasn't changed since the previous frame, but I'll leave that to you. Once this function determines the direction, the only remaining action for the player is to press the evade button, which is handled in the evade function. Before executing any logic, we first ensure that both the main character reference and the evade direction are valid. If either is not valid, we simply return early. This step is crucial because, in C++, it's a best practice to always verify the validity of pointers before accessing them. For example, if you want to display a message on the screen and the G-engine pointer isn't validated, the engine could crash. So, always make a habit of checking pointer validity to avoid such issues. Anyway, let's move forward. Once the player presses the evade button and we have a valid evade direction, we start by setting the isEvading flag to true, indicating that the character is now in the middle of an evade action. As mentioned earlier, this step is critical because it informs other game mechanics that the player is busy performing an animation, preventing any other input from interrupting the evade. Additionally, this flag helps avoid issues like spamming the evade button, which could cause the animation to restart repeatedly, ensuring a smooth and uninterrupted evade sequence. Since my character holds a weapon by default, playing the evade or dodge animation can look awkward, so I decided to hide the weapon during the evade period. I do this by accessing the character's mesh and changing its material to a transparent one. Once the animation finishes, I restore the weapon by changing its material back to the original. That's why I grab a reference to the main character class here, so I can use it outside this function, and I'll show you how this works when we implement the animation montage blendout delegate. To play an animation montage from C++, we first need to access the anim instance. This can be done by calling getAnimInstance on the character's mesh. At this point, we already know which direction the player wants to dodge, so we can ensure the corresponding animation is played. The evade section name must match the appropriate section of the montage for the dodge direction, allowing us to jump to and play the correct animation. We create a simple switch statement to select the appropriate section name based on the evade direction. After that, we check if we have a valid anim instance and a valid evade montage. Once confirmed, we call the montage play function on the anim instance, passing in the evade montage. Immediately after that, we jump to the correct section in the animation montage using the evade section name we previously set. At this point, the evade or dodge animation starts playing, which is great. However, once the animation finishes, the player can't move, look, or jump because we set the isEvading flag to true and never reset it to false. This will cause the player's locomotion system to stop functioning until the flag is switched back to false. There are a couple of ways to handle this. For instance, we could create an animation notify to handle this task, or loop through the animation duration and then reset the flag to false at the end. Both of these solutions would work fine. However, Unreal Engine's montage system provides some useful delegates that we can subscribe to, such as blending out and blending in. As the name suggests, the blending out delegate is triggered when the animation starts blending out, while the blending in delegate is triggered when the animation finishes blending in. To subscribe to the blending in and blending out delegates, we first call the functions montage set blending in delegate and montage set blending out delegate. For each function, we need to pass the corresponding delegate types along with the evade montage. After that, we bind a function to the delegate. This type of function is known as a callback, which automatically gets executed when the delegate is triggered. So we need to create two delegate types along with two different callback functions. Let me quickly show you how to do this in the header file. We define the first delegate on montage blending out started. As I explained earlier, this delegate is called when an animation montage begins blending out, typically indicating the end of the animation or a transition to another montage. The second delegate is of type on montage blended and ended. This delegate is triggered when the blending in phase of a montage is complete, indicating that the montage has fully blended in. Now to perform any tasks, we need to bind the callback functions. It's important that the function signatures remain unchanged. The blending out delegate takes an additional parameter, which is a flag indicating whether the animation was interrupted. However, we won't use this parameter in our implementation. To bind these callbacks to the delegates, we use the bindUObject function. This binds the callback function to the current instance of the class, ensuring that the function will be called when the montage blending out or blending in events occur. Finally, we need to implement the callback functions. Let's begin with the blended and ended callback function. This function is triggered when the evade animation has fully blended in. At this point, we could, for an instance, display a message or reduce the player's energy, but in this case, I would like to play a sound. So, if an evade sound is assigned, we simply play a 2D sound. The more significant actions occur in the blending out callback function. This function is called when the evade animation starts blending out, indicating that the evade is about to finish. Here we should reset the isEvading flag and evade direction to their default values, allowing the character to resume normal actions such as moving, looking around, or jumping. Additionally, in my specific case, I also need to reset the weapon material back to its original state. Now let's return to the editor and run the game to check the results so far. Awesome! Everything looks great. I'm pressing one of the movement inputs to select the dodge direction, and then I press the left control key to perform the dodge. However, there's a slight issue with the current setup that we need to fix. To illustrate this, let me eject the player and select the character blueprint instance. Watch carefully as the evade direction changes immediately when I move, and it stores that value every frame. This is problematic because if I move forward, for instance, and then stop, the movement should be 0. However, since the evade direction is already stored, if I try to press the evade button, the evade action will still trigger. This is not the behavior we want. We want the player to press both the directional input and the evade button simultaneously. This issue arises from how we handle input. For instance, we could check each time if the player has pressed both the directional input and the evade input simultaneously. However, this approach would add unnecessary code and overhead. Another solution could be to use chord trigger inputs. If you're not familiar with chord triggers, check out my previous tutorial where I explain them and how to create these types of triggers in C++. However, as I mentioned at the beginning of the video, using chord triggers would add more complexity to the system since we'd have to send multiple pieces of information between various classes. Using an enum to select the dodge direction simplifies this process significantly. In summary, if the player presses the movement input but does not press the evade button within a short period, we should reset the evade direction. The dodge action is intended to trigger when both inputs are pressed simultaneously, and we can easily achieve this by utilizing timers. Let's explore how we can implement that. In the sendMovementVector function, we receive the movement input and, after determining the evade direction, we set a timer to automatically reset the evade direction after a specified delay. The setTimer function requires several parameters. First, it needs a timer handle variable. fTimerHandle is a struct in Unreal Engine that is specifically designed to keep track of a timer. This allows us to manipulate or clear the timer later if needed. When the timer completes, it triggers the resetEvadeDirection function, which is responsible for resetting the evade direction. The resetEvadeDirection time rate is the duration, in seconds, after which the timer will call the resetEvadeDirection function. I've set this to a small value, such as 0.1 seconds, in the constructor. Now let's quickly look at the resetEvadeDirection function. It simply resets the evade direction. We could also reset the evade section name, but it's unnecessary because we already check the evade direction state in the evade function and perform an early return if needed. Now let's head back to the engine and run the game to observe the difference in behavior. Let me eject the player and select the character blueprint instance so we can monitor the evade direction variable. Notice how the value resets to none after 0.1 seconds if I don't press the evade button within that brief period after moving. It's a subtle difference, but it's an important one. Now, one final adjustment we can make is to change the forward dodge animation to play a roll animation instead. Let's try that. As you can see, I also have roll animations for the left and right directions, but, as I mentioned earlier, they aren't functioning correctly, so we'll focus on the forward roll animation for now. Since the forward roll animation is longer, the sections aren't aligned properly, so let me quickly fix that. Awesome! As you can see, since we're using root motion animations, they look much more natural. I also forgot to show you how to enable root motion. It's quite simple, so let me quickly demonstrate that. Let's open one of the animations, such as the forward roll. In the asset details, search for root motion and make sure to check the Enable Root Motion box. Now that will be a wrap. Thank you for watching. I hope you learned something new today and found the video helpful. If so, please subscribe to the channel and give the video a like. Thank you again, and see you soon.